Chapter 4, Lesson 5 of Pre-Calculus, and in this lesson we want to take a look at the tangent function. We've already looked at the sinusoids, the sine function and the cosine function, and I have a picture of the cosine function here, and we'll use that to review or to help us draw the tangent function, as you'll see in a few moments. Before we get to the tangent function, though, I want to review the unit circle because there's a relationship between the tangent and the sine and cosine on the unit circle that hopefully will make the graph appear clearer to you. If we're on the unit circle and this radius is 1, then at the 0 angle here, the coordinate of this point on the circle is 1, 0. As we rotate counterclockwise in the positive direction, at this angle here, which is pi over 2, this point on the unit circle is 0, 1. We continue to rotate in a counterclockwise direction. This here is the angle pi, and the coordinate of this point is -1, 0. And as we rotate further, this is 3 pi over 2. The coordinate of this point on the unit circle is 0, -1. And then as we get back around here to 2 pi, we are again back at the point 1, 0. Now you remember, because we're on the unit circle, that the cosine of the angle on the unit circle is simply the x-coordinate of these points as you move around the circle. So the cosine is simply these x points at each of these angles. The sine, you remember, again, because the r value is 1 and in the denominator, the sine is the y value over r, which is 1, and so the sine value corresponds to these y values of these points as we move around the circle. Now, if you remember when we were evaluating these other ratios, the tangent function, you should remember, is the y value over the x value. So we would take the y value over the x value, and at this point you would see 1 over 0 would be undefined. So the tangent is undefined here. In a moment, hopefully you'll see even more clearly why that is. So if the tangent of the angle is y over x, and on the unit circle y is sine and x is cosine, we could rewrite the tangent ratio in terms of sine and cosine by putting y, which is the sine value, over x, which is the cosine value. So the tangent ratio could also be expressed in terms of sine and cosine as the ratio sine over cosine. Now, because the cosine is in the denominator, you remember from earlier this year when we worked with rational functions that if we have a denominator of 0, that creates an asymptote because the function is undefined at that point. So anywhere that we have a cosine of 0, we're going to have an asymptote for the tangent function because the tangent function has the cosine in the denominator. Alright, so let's look at the cosine function then and see if we can't find out where these values are. Again, this is the cosine function, and this is the 0 angle here, and at 0 the cosine is 1, so we have our value of 1 up here. Well, let me make this a little bit darker here. And then as we go around here at pi over 2, the cosine is 0. So because the cosine function is 0 here, this is going to be a 0 in denominator, so this is going to be a place where the tangent function is going to have an asymptote because the cosine function is 0 at this point. Then as we continue with this function, the cosine reaches its minimum here, and that's at the angle pi. When we get back to 3 pi over 2, we have another place where the cosine function is 0, and so we have another asymptote. Okay? And again, this is going to repeat. Then as we get back around here, the cosine's at 1, and then back at pi over 2 again, it's at 0, so we would have another asymptote. Every place along this graph where the cosine value is 0, we're going to have an asymptote. Okay, so right about here. All right, so this would continue periodically across the board here. Now, if we take a look at the unit circle, let's look back at the unit circle, then we'll come back to the graph. We notice that the tangent function is the y over the x. So at this point right here, at pi over 2, the tangent function is undefined up at this point. And then if we go down here, the tangent function is undefined here as well. Now, there's two ways to look at this. We can look at this in terms of being pi over 2 in the positive direction and pi over 2 in the negative direction. So we notice then that the tangent function is going to be split over the y-axis. Now, what do I mean by that? Well, let's go back to the graph. We notice at the 0 function, this is at its maximum point, so this would correspond to this point here. If I go pi over 2 in the positive direction, when I reach pi over 2, I have a 0. So this distance here is the pi over 2 in the positive direction. If I go in the negative direction and go pi over 2, if I go pi over 2 in this direction, then I reach the other asymptote at 3 pi over 2 if I went positive. So you'll see that the tangent function is split around this y-axis. Half of it is on the right and half of it's on the left. And this is where we're going to begin graphing, is we always want to split that around the y-axis so that half of the function is on one side, half is on the other, because that's how it is going to look around the circle. Now as you continue, then it reaches its minimum. That's over here. At here, this is another pi over 2, and this is another pi over 2. So as we look at this then, what is the period of the tangent function? Well, we can see that the tangent function goes from this asymptote to this asymptote. And this is pi over 2 and this is pi over 2. So the period of the tangent function is pi. So unlike the sinusoids, whose period was 2 pi, the period of the tangent function is pi. Now you remember when we had the sinusoids, the period equation was 2 pi divided by the b value. And the tangent period is related to the b value in the same way. So the period of the tangent function is going to be pi over the b value. Okay, again, the only difference is this value that's in the top, because the tangent period is pi rather than 2 pi, but we'll use the same relationship between the b value, the horizontal stretch or shrink, in terms of doing this. Okay, so let's take a quick look then. What does the graph look like? Now that we kind of know what the boundaries are, what does the graph actually look like? All right. We know, let's go back to our unit circle and see if we can't figure it out. We realize that at 0, the tangent function is going to be 0, because 0 over 1 is 0. So we realize that when the x value, the input angle, is 0, the value of the sine, the value of the tangent is 0. Now, if you think about what happens as this goes around the circle, remember sine over cosine. Something interesting happens at the 45-degree angle. Do you know what it is? What happens at 45, 45, 90 in terms of the sine and cosine? Well, because the sides are the same, you remember that the value of the sine and the value of the cosine are identical. So the tangent is a sine over a cosine, the exact same value, so the tangent is actually 1. So at 45-degree angle, this tangent has reached a value of 1. And if we go in the negative direction, again at the 45-degree angle, the tangent reaches a value of -1, because the y value here is negative. One of the values is negative. So this is halfway between these. So you can see that the pi function is very nicely divided into 4 equal parts, much like the sine and the cosine was divided into 4 equal parts when we were graphing it. So what are the 4 equal parts graphically? Well, if we take the period of pi and we divide that in half, and then we take those sections and divide those in half, we have our 4 sections. So this would be 0, this is pi over 2 here, and then this would be half of that, or pi over 4. And we just talked about, we know that at 0, the value of the tangent is 0. If we go in the positive direction, when it reaches this 45-degree angle, the value of the sine is 1, so a y value of 1. If we go in the negative direction, at the 45-degree angle in the negative direction, the tangent value reaches a -1. So we have this value here, -1, 0, 1. Those are kind of my 3-point pattern as I go around, or as I go through the tangent function, -1, 0, and 1. So then the function gets close to the asymptotes, it comes through here, and then goes up closer and closer to the asymptote, but never reaching it. And then again, each period is divided the exact same way. So we divide this in half, we divide those in half. At the first 45, we're at -1. At the next 45, we're at 0. And then at this 45, we're at +1. And it comes through and repeats this pattern as we go this way and this way. And then again, in this period, we divide it in fourth. We have a pattern -1 at this value, 0, and then 1. And so then we can draw the graph as it goes through here and here. And again, this repeats all the way infinitely to the right in the positive direction and infinitely to the left in the negative direction. So this is the value, or this is the graph of the tangent function. So to review very quickly then, the period of the tangent function is pi rather than 2 pi. The period can be determined from an equation by doing pi over b. We want to split the tangent function around the y-axis, with half of the function being on the right in the positive direction and half being on the left in the negative direction, which corresponds to starting at 0 and going to pi over 2 positively and then pi over 2 negatively. And then we simply divide that into 4 equal sections. Our pattern is -1, 0, 1. So at the first 45-degree mark, we're at -1. At the next 45-degree mark, we're at 0. 45 degrees after that, we're at +1. And then it climbs this way. Okay? So that's the tangent function. That's how we would graph it. Now I'm going to take about 2 or 3 minutes at the end here and talk about the transformations in the tangent function. Pretty much a review, so I'll cover it pretty quickly. So we have the tangent function, the parent function, y equals tangent theta. And again, all the shifts that we've done throughout the years is applicable to these functions just like any other function. We're going to go back to using vertical stretch and horizontal shrinks and those types of words. We do not use words like amplitude and phase shift. Those only apply to those sinusoids. So very quickly then, if we have a vertical stretch, that's going to show up in the front of the function just like always. If we have a horizontal stretch or shrink, that's going to show up in front of the b value. So we have b and then theta, or in front of the x value. If we have a shift right or left, that's going to be subtracted from the x value. And if we have a vertical transformation up or down, that's going to be outside here. We can put a negative sign and reflect this over x. We can put a negative sign in here, reflect it over y. So the only thing we have to remember then is if we have a b value in here, we're going to have to factor it out in order to see the shift. So very quickly, let me do one example for you. Let's say we had -3 tangent 4 theta minus pi over 4 plus 3. So what are the transformations of this function? Well, you remember our negative sign is going to reflect the function over the x-axis. All right, so that reflects it over the x-axis. The 3 is a vertical stretch of 3. And again, we're not going to use amplitude. Those are only for sinusoids. We'll take a look here. This 4 tells me that I have a horizontal, and this is a horizontal shrink. You remember that it's the reciprocal of what I see, so it's a horizontal shrink of 1/4. Now let me put this here by factor of 3. The horizontal shift right or left will have to factor out that 4 in order to see that. So if I factor out 4 from theta, that means I have to divide by 4. That means I'm multiplying by 1/4, so this is pi over 16. So that means we're going to have a shift to the right, pi over 16 units. And then this value out here is a vertical shift or vertical transformation up 3 units because it's outside. So all of the things that we've done before as far as transformations are all the same when we're talking about these tangent functions. Okay, so I'm going to wrap that up here. We'll take a look at some, I'll do an example video where we'll graph a few of these so you get the idea of how to do these moving forward.